Another one of the special cases of trinomials and binomials that when you're trying to factor is factoring differences of squares. And this is number 11 on your assignment 9-5. The first thing I notice is, I only have two terms, so I'm going to check to see if it's a special case, the difference of square case. And I'm looking at it, and then even though sometimes we forget, the first step when you're factoring is to see if you can pull out a common factor, the greatest common factor, in fact, because on this one, I thought, well, 6 is even and 54 is even, so I can divide out by a 2. And so I did that, pull out a 2, and 6 divided by 2 gives me a 3 left for my first term. And 54 divided by 2 gives me a 27 left for my second term, a squared, because I didn't pull any a's out. But then I'm looking at the inside, what's left here, and I'm not very excited because I need to have some perfect squares in there in my terms, and 3 is prime and 27 is not a perfect square, and so I don't know how to factor from there. It's not meeting the special case that I need. So then I thought, oh, maybe I needed to pull out something else. I could pull out more. I can divide by 3, because 6 is divisible by 3 and 54 is divisible by 3. But in fact, if it's divisible by 2 and by 3, that means it's divisible by 6. So I can pull out a whole 6. So let's do that instead. If I divide by 6, 6 divided by 6 leaves me with 1 left, the first term. And then 54 divided by 6, that's 9. And then my a squared is also left inside. Now I'm seeing a special case because 1 is a perfect square, and 9 is a perfect square because 3 times 3 is 9. So pulling out the greatest common factor was really important here. So my 1 and my 1, and over here I've got an a squared also to worry about. I need to write that as a perfect square would be, for my second term, would be 3a times 3a. So I ended up getting the 9 and the a squared back. So now I can write my two binomials. And I know my first term in the first binomial is going to be 1. And I also have to have a 1 as the first term in my second one. And then the 3a. And the 3a, in the special case of a difference of squares, they have to have the same terms inside. The key is my signs make the middle disappear. And I've got a plus and a minus, so let's check to make sure that makes my middle disappear, so I only have 2 terms instead of 3, like I started with. Well, 1 times my negative 3a gives me negative 3a. Then 3a times 1 gives me positive 3a. And yep, that's 0. So I know that we've got it right. And you would probably rewrite it to clean it up before you circled that as your answer, because I've got some lines on there showing my work. So 1 plus 3a, and I'm going to make space for it. And another 1 plus 3a. Oops, one of them's a minus. And then you would be finished. And you would have it completely factored if you remembered that there was a 6 hanging out here. It's kind of hard to remember because we pulled him out. He was the greatest common factor to begin with, but he's a really important part of the answer because if we don't multiply by 6, we've changed the problem entirely. So make sure you keep hanging on to him, and I would have remembered if I had written him right there. And then my final answer, box it in, and we're done.